So the digital data control and digital waveform control contain data in digital tables. A digital table can represent data in 8 digital states. So we can use the build digital data function to build digital data tables. So let's right click and create a constant. And let's specify the digital values 0, 1, 2, 3, 4, 5, 6 and 7. Let's create an indicator, clean up the diagram, and let's have a digital waveform to view the data as well in the graphical format. Let's connect the wires and clean up the diagram. Go to the front panel, run the VI once, arrange the front panel so that we can see the values. So let's just hide this label, and so the value of 0, which means drive low, it forces the logic low. It drives to the low voltage level V, and in the subscript is OL. Then we have 1, value of 1, which means drive high. It forces the logic high and drives to the high voltage level. Let's call it VOH. OH is in the subscript. Then we have number 2, value of 2, which is Z, which forces off, which means that it forces the logic high impedance, turns the driver off. Then we have number 3, which is L, which means compare low. It compares the logic low edge. It compares a voltage level lower than the low voltage threshold. Then we have value of 4, which is H, which means compare high. It compares the logic high edge and compares a voltage level higher than the high voltage threshold. Then we have number 5, value of 5, which is X, and it compares, it means compare unknown. It compares logic unknown, that is does not compare. Then we have value of 6, which is equivalent to T, which means compare off. It compares a logic high impedance edge and compares a voltage level between the low voltage threshold VOL and the high voltage threshold VOH. And last we have value 7, which is equivalent to V, which means compare valid. It compares logic valid level edge. It compares a voltage level either lower than the low voltage threshold VOL or higher than the high voltage threshold VOH.